Welcome to Mrs. Z's Chemistry. In this video, we'll learn about physical properties and changes, as well as chemical properties and changes. A physical property is a characteristic of matter that doesn't involve the chemical compound changing. So for example, density, color, the hardness of a substance, melting or boiling point, and whether or not it can conduct electricity. All of these are physical properties of substances. A physical change is a change in the phase or state of matter without the chemical compound changing. A substance changing from gas to liquid, liquid to solid, or solid to liquid are all physical changes. Here's a list of some other examples of physical changes. Wax melting, sugar dissolving in coffee, steam condensing into liquid water, ripping, tearing, breaking, or chopping a substance, or grinding a substance into powder. The difference between physical changes and properties is the property states a fact about the substance. For example, the boiling point of water is 100 degrees Celsius. The water isn't changing right now, but we have just stated the temperature at which it would boil. If you have water in a pot on the stove with the stove turned on, the water will then boil, and that is the physical change. So here are some images showing physical changes. Crushing a can, melting an ice cube, boiling water, mixing sand with water, breaking glass, dissolving sugar in water, shredding paper, chopping wood, mixing green and red marbles, or the sublimation of dry ice, which just means a substance, sublimation means a substance changing from gas to, or a solid to gas, skipping the liquid phase. So all of these examples are just physical changes. The substance has not changed itself. The chemical compound is the same. Now we're going to look at chemical properties and changes. The ability or inability of one type of matter to change into another is called a chemical property. Flammability, toxicity, acidity, or unreactivity are some examples of chemical properties. Iron, for example, combines with oxygen in the presence of water to form rust, which is called oxidation. Iron's ability to oxidize is a chemical property of iron. Chromium's inability to oxidize or rust is a chemical property of chromium. Nitroglycerin is a very dangerous substance because it explodes easily, whereas neon possesses almost no hazard because it is very unreactive. These are all chemical properties of these different substances. A chemical change always produces one or more types of matter that are different from the matter present before the change. For a chemical change to take place, a chemical reaction takes place. We'll look at chemical reactions in more detail in Chapter 4. The formation of rust is a chemical reaction between iron and oxygen and water to form an iron oxide or rusted iron that is completely different chemical compound than the original reactants. The explosion of nitroglycerin is a chemical change because the gases produced are very different kinds of matter from the original substance. Here are some changes showing some images showing chemical changes. Iron rusting, burning wood, metabolism, cooking an egg, baking a cake, electroplating, rotting banana, vinegar and baking soda mixture, fireworks, and chemical battery. For every single one of these images, a chemical reaction is taking place, which means a chemical change is taking place. The chemical compounds of the substances after the change are different than those before the change. Properties of matter fall into one of two categories. If the property depends on the amount of matter present, then that is an extensive property. The mass and volume of a substance are examples of extensive properties. For instance, a gallon of milk has a larger mass than a cup of milk. The value of an extensive property, the mass of something, is directly proportional to the amount of matter in question. If the property of a sample of matter does not depend on the amount of matter present, then that is an intensive property. Temperature is an example of an intensive property. If the gallon and the cup of milk are each at 20 degrees Celsius, room temperature, when they are combined, then the temperature remains at 20 degrees Celsius. As another example, consider the distinct, which means different, but related properties of heat and temperature. A drop of hot cooking oil splattered on your arm will cause some brief and maybe minor discomfort, whereas a whole pot of hot oil at the same temperature as that one drop would yield very severe burns. Both the drop and the pot of oil are at the same temperature, which is an intensive property, temperature, but the pot clearly contains much more heat. Heat is an extensive property. Here are some images illustrating the differences between intensive and extensive properties. Remember that intensive properties are independent of the amount you have. It doesn't matter how much you have, boiling point of water will stay the same, whether you have a drop of water or a whole swimming pool of water. Whether you have a tiny fleck of gold or a huge gold nugget, you're going to have the same color. Gold will have the same color no matter how much you have of it. Temperature, the luster or dullness of a substance, as well as the hardness or brittleness or malleability of a substance, do not depend on how much you have. Extensive properties specifically do depend. The property of mass will change depending on how much you have of it. Volume, mass, size, weight, and length are all extensive properties. While many elements differ dramatically in their chemical and physical properties, some elements have similar properties. For example, many elements conduct heat and electricity very well, whereas others are very poor conductors. So these properties can be used to sort the elements into three classes: metals, nonmetals, and metalloids, which are intermediate. They can sometimes conduct well, or some of them do not conduct very well. The periodic table is a table of elements that places elements with similar properties close together. On this image, you can see the elements with a green background in this corner here. They are all nonmetals, which are the elements that conduct electricity or heat very poorly. The purple background, the ones kind of in the middle here, the purple background are the metalloids. They are the intermediate conductors, and the yellow background elements are metals, and they are good conductors of both electricity and heat. You can see most of the periodic table are metals. Any element symbol written in black is solid at room temperature. Notice most of the metals are written in black. They are solid at room temperature. The blue elements, of which there are only two here, bromine and mercury, they are liquid at room temperature. And the red ones are gaseous at room temperature. We'll learn more about how the periodic table is organized by property and similarity over the next few chapters. Let's go to the periodic table here. This is the periodic table that you'll get to have on every quiz and test and final exam in my class. So make sure to have it handy during class and when you're studying at home. The more familiar you are with where everything is, the better time you'll have during the tests. As you can see, there are many equations and unit conversions on the back of the periodic table.